I have made this video to just try to show you my reaction to how math is being taught, or my perception of how math is being taught, and the difficulties that it creates for the student. Part of the problem is that our professors don't necessarily have full knowledge of the subjects that they are presenting. And I will try to illustrate this with this particular example. I watched several YouTube videos for finding the Maclaurin series for 1 over 1 plus x. Except for one, they all found the most difficult way to get half the answer. One did use the approach I'm going to show you, but he too found half the answer. That's what I'm addressing in terms of knowledge of the presenter. We usually repeat what we are taught, often without asking whether there is another or better way, or whether there's more to the problem. The secret to learning. The conventional way of finding the infinite series is to use differential calculus. However, there's a far easier way by just using elementary division. However, after we find the answer, we find it only works for the values of absolute x less than 1. This is where our math teachers have stopped, or at least with me. Half the problem, and in fact, this range of between -1 and 1 is a tiny fraction of the full range of 1 over x. But if you look closely at the series, you discover that it diverges for 1 and -1. But for -1, that's okay. However, by presenting the series by a geometric series formula, we can find that the series each approach 0.5 as x gets closer to 1. This approach was used on one of the videos that I will provide a link for. After looking at this lesson, ask yourself how you got smarter. Okay, here is the division for doing division of an arithmetic function. We're basically trying to eliminate or reduce to 0 the remainder. So we first try a trial divisor of 1, multiply it by 1 plus x, subtract it, and that leaves us with a remainder of minus x. Okay, then we want to eliminate the minus x. So minus x is our divisor. Minus x times 1 plus x gives us minus x squared. And subtracting again eliminates the minus x. Now, what we'll notice is that the remainder is some power of 2. And as we get further and further down the line, high powers of 2. If x is less than 1, those powers of x will begin to get very close to 0. But if x is greater than 1, the remainder just blows up. Okay, so after doing this, we can see a pattern of a exponential series with alternating signs. Okay, if the division is to occur, as I mentioned before, x to the n has to approach 0, and with n being greater than 1, that would not happen. Now, we will need another piece of information in order to do this problem, and that is to sum up a geometric progression where we can get the sum up to some point in that progression. And it turns out that this function that we get, or series, is a geometric progression. So I show the derivation of the formula here, where we basically eliminate the middle terms and are left with the first and last terms. And this is our formula. And we can see here, if b, which will be x in our case, is less than 1 raised to a very high power, this begins to approach 0. Now, and we then get back our original function. However, let's just see if the formula really works for some short range. So we have b is minus x and a is 1 in comparison to the numbers in the geometric formula. And sure enough, it does give us 1 over 1 plus x. But to check this out, we have to put values in for x, and we'll pick 0.5. And doing that, we can calculate an exact value for 1 over 1 plus x. That comes out to 0.666, or 2/3. If we take the series and sum it up to the first 4 or 5 terms, we get close to 0.66. And our intuition would tell us that eventually we would get exactly if we took enough terms. Okay. Now, it turns out there's another way of making that 1 disappear. If we multiply 1 plus x by 1 over x, we get x over x, which is 1. And when we subtract that, we get minus 1 over x. And we continue in the same way that we did with the first series, except this time, instead of getting powers of x, we're getting powers of reciprocal x. And in this case, if x is a very large number, then the remainder does approach 0 rather quickly. If x is less than 1, then it diverges. So this series works where the other series didn't work, but a far greater range. Okay, now just to check out that this series does represent 1 over x, we again use the geometric formula, except this time b is minus 1 over a and a is 1 over x. And we put it in, sure enough, we get the same value again. Okay, and again, to test this formula out, we put in a value of x is 9. And when we check it out, we get from the 1 over x, 0.1. And if we try the first few terms, we get a number 0.100, which is pretty close to 1. So this builds us up confidence in the fact that these formulas do work. Okay, so now let's take a look at what we've done. We've got 2 series now to represent that function. One in the small range of minus 1 to 1, and then a bigger range outside that with a series that we normally don't see or shown, particularly in the videos that I've discussed. Now, what we also find, there are some points that we have to look at closely, and that is if we look at x equal to 1, the series would diverge or bounce back and forth between minus 1 and 1. Okay, and we find if we use that series, which represents it, we can show that if we get very close to 1, but not to 1, this series will converge very slowly to 0.5. Okay, when x equal to minus 1, we get infinity and our function diverges. So we're not concerned about that value for evaluation. So we have discovered that what we need 2 series to define or evaluate that function. We discovered a way to get around the diversion of x at exactly x equal 1. I searched the YouTubes that found this series for 1 over 1 plus x or 1 over 1 minus x. All of them found a more difficult way to find the first series. None bothered to find the second series. And if you look in this area, you can barely see what those things. But if you want to go to YouTube, just put in the search value of 1 divided by 1 minus x or 1 divided by 1 plus x, and you'll get a list of those videos. Okay, now, for academic purposes, I showed you how to get the answer to the problem. Okay, but if we're actually doing the problem, it makes it much easier to comprehend is if we do find both series at the same time, as I've shown you on this page. The next page I then dedicate to finding the sum of a geometric series and some checking of work, which is very important. Okay, so summarizing what we've done is we've found what 1 divided by 1 plus x is, and even have noted that it becomes divergent when x is equal to minus 1. And then we show that both series diverge, and we show that using the geometric formula, that the answer that we get is 0.5. So, in summary, we have shown how to fully solve the problem. We've shown through some YouTubes that people have not solved the problem because it would not be easy to go into a classroom and photograph, somebody teaching this. But, my own personal experience has shown that in this case, by using what I was taught, I could then go beyond what the teacher had taught me. So this is basically showing that in learning to do math, that there are some subtleties which this illustrates, in which we have to design the lesson so that the student is figuring out the problem, so he begins to get the experience of solving a problem that he's never seen before. Thank you very much.